In lesson 65, we will be learning the derivatives of arcsine, arccos, and arctan. In year 1 of your IBHL course, you learned about the graphs of the inverse trig functions. And because a periodic sinusoidal function is not a one-to-one function, you have to make sure you restrict the domain in order for the inverse of those functions to also be functions. So let's take a quick look at the graphs of arcsine x, which is a function if we restrict the domain to -1 and 1. And the y values will go from negative pi over 2 to positive pi over 2. Let me put a negative sign here. And then for the graph of arccos x, again, the domain is from -1 to 1, open interval, and the range is from 0 to pi. The graph of arctan actually has its domain spanning the entire set of real values, but the range goes from negative pi over 2 to positive pi over 2. And because of the asymptotes that you usually see at angles, theta equals a negative pi over 2 to positive pi over 2 on the graph of y equals to tan x, there are horizontal asymptotes on the graph of arctan x. Now let's turn our focus into looking at the derivatives of these inverse trig functions. We will first try to derive the formula to find the derivative of arcsine x. I have included a diagram of a right triangle and let one of the acute angles to be arcsine x, which implies that the opposite over hypotenuse ratio in this particular triangle will be x over 1, as indicated on the diagram. Once we have set y equals the sine or arcsine of x, I can write x in terms of y by taking sine of y equal to x. Let's try to differentiate this expression using implicit differentiation. The derivative of sine is cosine of y dy by dx equals to the derivative of x, which is 1. Now we're going to write dy by dx as 1 over cosine of y. What does this mean in terms of x instead of cos y? Let's go back to the diagram. Using Pythagorean theorem, I can actually figure out the third side, the bottom side or the adjacent side to the angle y as 1 squared, 1, minus x squared, all square root. In other words, cosine y in this particular triangle is adjacent over hypotenuse, which is 1, and we don't have to write that down. As a result, the derivative of arcsine x is 1 over the square root of 1 minus x squared. Now, let's take a look at example 2. Let's show that the derivative of arccosine x is the negative of the derivative of arcsine x. We can follow some very similar steps that we have taken in example 1 in order to figure this out. We will first let y to be arc cos x. Okay. We can also label on our triangle, well, since arc cos x is the angle, that means the cosine ratio in this particular triangle is x on the adjacent side and 1 on the hypotenuse, making the opposite side 1 squared minus x squared, all square root. Okay. Going back to our expression, I can now write cosine of y is equal to x. differentiating implicitly, negative sine y dy by dx must equal to 1. And so dy by dx is negative 1 over sine y. Now, what is sine y on this diagram? Let's take a look. It's the opposite side over hypotenuse, which is 1, so we don't have to write that. Which means dy by dx is negative of 1 over the square root of 1 minus x squared. Look familiar? Indeed, because this is the negative of the derivative of arc sine x. And we have shown what we're required to show. You can follow very similar procedures to figure out the next question. So why don't you pause the video now, try the question before coming back to look at the answers. Okay, I hope you took the time to try example 3. Let's take it up. The angle y is arctan, so opposite is x over adjacent is y, making the hypotenuse 1 squared plus x squared square root. I'm gonna let y equal arc tan x, which means tan y is x. Differentiating implicitly, I have secant squared y dy by dx equals to 1, which means that dy by dx is equal to 1 over secant squared x. Well, 1 over secant is cosine, so this is cos squared y. Okay. What is cos squared? Oh, cosine from the diagram. Cosine is adjacent over hypotenuse. So let's make more room on the side. That means dy by dx is 1 over 1 plus x squared square root, but then we square that again, which means that indeed derivative of arctan x is 1 over 1 plus x squared. Now we will take a look at some examples of inverse trig functions and their derivatives. Make sure you know that the following formula are given in your formula booklet. But if you're taking the arcsine of a function other than x, make sure you still remember to use chain rule. Let's differentiate y equals the arcsine of 3x squared. The general form is pretty clear here. It's an arcsine, so we'll be making use of the first function. However, it's not clear how that 1 minus x squared will change if now I'm taking the arcsine of 3x squared. One quick way to look at that is to construct your right triangle. It's not very good, but that's okay. And here is your angle y. Since we're dealing with sine, opposite is 3x squared over hypotenuse 1, making the bottom side 1 minus 9x to the power of 4 square root. Now see how this matches with the actual denominator of the formula for the derivative of arcsine. So we know that now the derivative of y will look like 1 over 1 minus 9x to the power of 4 square root, And then, don't forget, we need to take the derivative of the function 3x squared using chain rule. Putting that together, we have y prime equals to 6x over 1 minus 9x to the power of 4 all square root. Okay. This time we have arctan of a quadratic. It's a very similar idea. The formula booklet tells us that the format of arctan x is 1 over 1 plus x squared. So let's make a right triangle first. So here, let's let this angle to be arctan of that quadratic. Tan is opposite over adjacent, making the opposite side ax squared plus bx plus c, and the adjacent side 1. Meaning the hypotenuse is 1 squared plus the square of the quadratic, all square root. However, we know that in arctan, the formula says we have to square the x squared part. So now I know that this is going to be the derivative. 1 over 1 plus ax squared plus bx plus c all squared, and then multiply by the derivative of that same quadratic relation. Okay, which turns into 2ax plus b all over 1 plus ax squared plus bx plus c squared. If you want to try to do question C by yourself first, pause the video until you're done, okay? Here is question C. I noticed that there is a coefficient of -5 that I can set aside and use product rule to take the derivative of x times arc cos 2x. I also know that eventually I will need this triangle to help me figure out what's related to arc cos 2x. Meaning adjacent side is 2x, hypotenuse is 1, and the opposite side is 1 squared minus 2x squared, which is 4x squared, square root. Okay, so y prime is -5 times the derivative of x is 1, arc cos 2x stays the same, plus x multiplied by the derivative of an arc cos. What would that be? Use the chart. Arc cos is -1 over square root of 1 minus x squared. So we're going to have -1 over, using the triangle, I know that this will be 1 minus 4x squared. And then take the derivative of 2x. Like that. Expanding, this gives me -5 arc cos of 2x. And let's see, I have -5 times a negative in the second term, so it turns positive. Derivative of 2x is 2 times 5 is 10 x. And then the square root of 1 minus 4x squared. Looks good.